going to wrap up the course, okay? And we are going to have a look at the topics that we have covered over the semester, okay? And just to do a little bit of a revision and a summary of what we have covered, okay? And try to see the connections between all the topics. In geospatial engineering, the connections, as well as how we can apply, okay, what we have learned, okay, in maybe in the field of civil engineering or in any other fields that might be relevant later on. Okay, so before we start the class, can you please switch on your camera for a while for me to record your attendance? Right. Please switch on your camera, everyone. Okay, so masih ramai yang tak on camera ni. Okay, this is the last class, so it is very important for me to record, okay, your presence. I hope for a full house. Okay, so right, I'm going to capture the screen. Okay, smile. 1, 2, 3. Okay, once more. Wait. Okay, smile. 1, 2, 3. Okay, so thank you, everyone. All right. Okay, so let's discuss on what we have covered. Okay, I'm going to share my slide, my summary of what we have covered, okay? Can you see it?
Yes, sir.
Okay, boleh nampak eh?
Boleh, Doktor.
Okay, so Anyway, my apologies for the for the very bad graphic design. Okay, for this slide, because I just finished this summary late last night. Okay, so because I think I was not planning to do any diagram to summarize, but I think that it will be better if I can present it using a diagram like this. Okay, but anyway, is I haven't got enough time to properly design it. So okay, my apologies for that. So it's a very rough diagram. Okay, I haven't got enough time to polish it properly. Okay, but anyway, I think what is important is that as you can see from this diagram, from this figure. Okay, as you can see from this figure, okay, basically, I'm trying to summarize all the things that we have covered, okay, throughout the semester. Okay, there might be something missing as well here that probably you can add to it, okay, as we go through our discussion this morning. Okay. Okay, so throughout the 14 weeks, we have covered, okay, we have covered all the topics in geospatial engineering through lectures, through we also have invited speakers to our course. We also have attended several webinars that are relevant, okay, to this course. We also have done hands-on sessions with the assistance of Mr. Yu Hao. And you have also done several assignments and practical reports. Okay, so those are the things that we have covered in terms of the class activities. Okay, in terms of the topics that we have covered. Okay, firstly, we have discussed about. I mean, in general, in this course, there are 4 to 5, okay, maybe 4, I would say. There are 4 main topics that we have covered. Okay, the first one is on remote sensing, and second one on GIS, the third one on GNSS, and also on data science. Okay, these are the 4 core topics that we have covered throughout the semester. Okay, just to revise on what we have covered in remote sensing. Okay, can you still recall the different types of sensors, the different types of platforms, and different ways of processing the remote sensing data? Can you still remember what we have covered? Okay, so these four, we call it topics, will definitely be in the exam. Okay, and you will be, I can ask you anything related to geospatial engineering technologies. Okay, and in terms of the technical facts, as well as open-ended kind of questions. Okay, so in remote sensing, for example, okay, in remote sensing, we have discussed about various sensors. Okay, for example, multispectral, hyperspectral, lidar, radar, as well as thermal sensors. And I'm sure that you can classify the sensors into active as well as passive kind of sensors. And I believe that you are well aware of what you call it, the basic designs and also the basic fundamental of the operations of the sensors. Yeah. Okay. And we also have discussed about various platforms, okay, that we use to acquire remote sensing data. Most importantly, those from satellite platforms, UAV, as well as aircraft. Yeah. What else? Did I miss anything in terms of sensors and platforms? Anything that maybe you would like to add? Or any comments or any questions? Don't be too passive. I mean, this is your final chance to ask me anything. Okay, maybe anything related to something that you don't understand or something that you need some clarification. Okay, before the exam. Okay, this is our final revision session. So be more active. Okay, to ask me questions. Okay, jangan senyap sangat. I mean, you guys are very quiet in the class.
I think we actually don't know what to ask so far.
So kalau you don't ask any questions, I will assume that everything is crystal clear.
InsyaAllah.
Okay, I'm glad I'm glad that everything is crystal clear to you guys. Okay, so meaning that I managed to deliver what is needed. Okay, so I will expect you to do very well in the exam. Okay, no matter how I ask you the questions, you should be able to answer. Yeah. Okay, so and also we have discussed about how we process remote sensing data. Okay, in terms of the workflow of data processing in remote sensing. Okay, so if you still remember, we have discussed about data acquisition. Okay, the data acquisition, when we talk about data acquisition, it relates to the usage of platforms and sensors and so on, okay, in order to acquire the raw data, okay. So before we can extract information, okay, from the remote sensing data, we have to start first with some cleaning of the data, okay, or correcting the errors in the data. This is called pre-processing. Okay, this is a process called pre-processing, where normally we will do.
So sorry, doctor.
Yes.
Yeah, you how here. I think I cannot see your slide.
That's why lah. I mean, kalau tak nampak you guys kena cakap cepat. Sebab sometimes I cannot. I don't know what is happening. Kadang tu it's gone missing. So how is it now?
Yeah.
Yes,
Okay.
Yes. That's why you guys kena proaktif, okay, dalam kelas. Because sometimes berlaku technical errors like this, you kena beritahu cepat. Okay, so right. Okay, so just now I mentioned about the workflow. Okay, the workflow, right? In remote sensing. Okay, so the workflow on how we process our data starts with data acquisition. Okay, and then the pre-processing part. Okay, the pre-processing part, okay, will involve the geometrical as well as radiometric and also atmospheric corrections, okay, to the data. Okay, so and after we have done the corrections to the data, Okay, we will do processing. In terms of the processing, normally we will do classification. Okay, that's the most common types of processing that we do. Okay, but there are also other processing involved, for example, object detection, okay, or segmentation and so on. Okay, so but the main processing that we are normally do, okay, with our remote sensing data is classification. Okay, and classification can be divided into supervised classification or unsupervised classification. Okay, and you should be able to explain, okay, what is the difference between the different types of machine learning techniques that we can apply to remote sensing data. Okay, for example, we have supervised learning, unsupervised learning, and also reinforcement learning, for example. But most importantly, the supervised and also unsupervised classification, or learning, the learning, the supervised or unsupervised learning can be divided into mostly classification or regression. Okay, but I think classification is enough, okay, for you to really understand, okay, because that's the main thing that we normally do, okay, in remote sensing. And after that, how we do the accuracy assessment, okay, how we perform accuracy assessment of remote sensing data. And after the accuracy assessment, how we present the results to the clients, okay. So whether you produce it as a digital output or as a hard copy output, or you put it into a database later on, and so on. So these are the things that you need to discuss. I think the workflow processing, okay, the workflow from what you call it, the end to end, okay, processing of remote sensing data is very important, okay, for you to be able to understand and explain, okay, the technicalities of the processing. Okay, and what else we have covered in remote sensing? Yes, today as well, I think the last part that maybe you need some exposure on is how we use Python in order to perform processing of remote sensing data. Last time, what software you have used in class? I think you have used QGIS, right? You have used QGIS, Nmap, or the Avios, okay, in class, okay. Those are software-based kind of processing. But today, Yuhao will be exposing you to the use of Python, okay, a purely programming kind of workflow in order to process remote sensing data. Am I right, Yuhao?
Yeah.
Okay, today you will be demonstrating the use of Python, yeah, in the
Yes.
Jupyter environment.
Yeah.
Okay. All right. So that's the thing that we haven't covered. So today Yuhao will be showing you, if you are interested to use Python, okay, to perform classification and so on, so that you can have the total control of your data science workflow. Then Yuhao will be showing you how we do that, okay, in the total programming environment. Okay, and then anything else you'd like to ask about remote sensing?
No,
Okay, so the next topic that we have covered is on GIS, or the Geographical Information System. Okay, so for GIS, we have discussed about the development of database, okay, in a GIS environment, how we develop a GIS database. So one of the sources of data for GIS is coming from remote sensing, and another can be also from any other types of data acquisition modes. Okay, can be from GPS, GNSS, can be from ground survey. Okay, can be from existing maps. Okay, from the authorities or from government or from open source. Okay, so GIS is about having or creating a database and use the database for further geospatial analysis. Okay, so we have discussed about database development. Okay, we have discussed about some of the techniques that we can do in order to perform analysis in a GIS environment. For example, we have used raster-based we call it analysis. We have used vector-based analysis. Okay, last time we have shown you some examples of how we can determine the suitable areas for development. Okay, based on GIS analysis. We also have discussed about how we use GIS analysis in order to we call it evaluate the risk of disaster for certain areas. Okay, so there are a lot of applications that can benefit from GIS analysis as well as modeling. Okay, so we have discussed many applications. You also have presented some interesting applications through your test 2 oral presentation. So we have covered GIS in that sense. Okay, and then we also have discussed about BIM or the building information modeling. We also have we call it an invited speaker, Mr. Anomat, last time talking about the integration of GIS and BIM. Okay, for we call it for the creation of digital twin. Okay, for example. Okay, so how we use, for example, UAV. Okay, we discussed about how we use UAV and LiDAR and also RGB camera, okay, in order to acquire data to develop BIM, okay, in order to develop we call it the data for BIM, as well as how we use BIM and GIS in an integrated manner, okay, to serve several applications, especially applications in the built environment or in the civil engineering sector. Okay, so we have discussed about that. Okay, and the next one is about global navigation satellite systems. Okay, or GPS. Okay, so in GNSS, we have discussed about the components of GNSS. Okay, so when we're talking about GNSS, it is not only GPS inside. We call it in the it's not GPS alone. Okay, you also have to remember that we have also other systems that we call it. We have several systems that are under the umbrella of GNSS. Okay. Can you remember what are some other systems that we have other than GPS? Can you tell me the names of some other systems as well? If you can still remember.
GLONASS.
GLONASS.
Yeah, so we have GLONASS. Okay, what else? What is the name of the system developed by Japan?
QZSS.
Okay, good. Okay, so you should be able to explain, okay, about the probably the different types of systems under GNSS and how GNSS how for example positioning is important in various applications, okay, and how we process and analyze the positioning data from GNSS. Okay, and then after that, we discuss a lot about data science. Okay, the basic principles of data science, because remote sensing, GIS, GNSS is, I mean, these things or these technologies are also contributing, or we can say that they are also part of data science in general. Okay, when we talk about data science, we are basically discussing about how we process data. Okay, data can be in many forms, in many forms and formats. They can be structured, they can be semi-structured, they can be unstructured. And we can see that in a lot of applications, okay, we have to combine different types of data, okay, before we make final decision. Okay, so a lot of things, not just in civil engineering, I mean, in any sort of applications and fields, okay, the industries are using data from, geospatial data as well in their analysis. Okay, so we have discussed about data science in general, okay, and how geospatial is part of data science, because geospatial is about data. Okay, we discussed about how we acquire data from remote sensing, how we acquire data from GPS, how we acquire data from field acquisition, okay, and how we use, for example, this data in the GIS environment. So the general principle of data science is relevant to what we do every day in geospatial engineering in order to help us in making proper decisions. Okay, so in data science, we use a lot of AI and machine learning. Okay, we use a lot of AI and machine learning techniques in order for us to develop models. Okay, in order for us to develop prediction models. Okay, and what else? We also have done classification through machine learning. We have done regression through machine learning. Okay, so in data science, AI and machine learning, we use, for example, Python. Okay, I also forgot to mention that we also use KNIME, okay, in a non-programming environment. Okay, we have either you use ready-made software in order to perform data science, or you can also use Python, or you can also use a low-code software like KNIME, okay, in order to perform our data science project. Okay, so, and we have discussed about cloud computing. Okay, how, for example, cloud computing is very important nowadays, because cloud computing helps us to store huge amount of data without us having to, invest in the infrastructure. Okay, so instead of having to buy servers, laptops, computers, and so on, okay, you can just subscribe to a cloud service, okay, and you can do storage. You can perform analysis in the cloud environment. Okay, so cloud is something that is very important nowadays, and it has basically revolutionized the way we deal with data. Okay, especially when we talk about big data. Okay, when we talk about we call it the use of AI and machine learning, the industry nowadays are moving towards cloud computing. So to understand the impact of cloud computing in our daily lives is very important. Definitely, I would be, I'm very much interested to ask you questions on the usage of data science, cloud computing, your understanding about big data. Okay, like last week we have attended the webinar from Dr. Obai on the usage of big data, okay, and also how we process big data in the cloud environment. So this is something very interesting that something I would like to ask you about. Okay, so try to enhance your understanding about cloud computing, big data, and so on. Okay, including IoT, a little bit of IoT, because we call it data coming from geospatial is also contributing, also part of the IoT networks as well. Okay, and then we also have discussed about various applications of geospatial engineering, especially I would like to see your understanding about how you can use everything that we have discussed just now, okay, in a civil engineering application. Okay, so as you are aware, there are a lot of applications in civil engineering that can benefit from geospatial data. Okay, and geospatial data can help to we call it can help you in making more accurate decisions, okay, or can help you to solve a lot of we call it sustainability requirements. Okay, so how geospatial data can contribute in this context, okay, and how we can use everything that we have covered so far in an integrated manner, okay, to provide a solution in a civil engineering application. So there might be also an open-ended question, okay, that will be asking you about the integration of everything that you have covered so far, okay, and how you can propose a solution. Okay, so there will be definitely an open-ended question like this, okay, in the exam. Okay, so I think that's all basically in terms of what we have covered, and also what you need to know, okay, what you need to be prepared for the exam. Also, I have mentioned, okay, just now. So anything that you like to ask?
I think so far no, Doctor.
Okay, good. Okay, so just now I have given you all the tips, okay, required for the exam. Okay, so as I mentioned, the exam, or as usual, the exam will be having two parts, part A and also part B. Okay, so part A is more straightforward, technical, direct to the point kind of questions. So part B is the where you have the open-ended questions, right? So, but I think it's not going to be difficult at all. Okay, as long as you understand all the points that I have mentioned just now. Okay, so it should be no problem. Okay. Okay, so if you don't have any questions about the exam, okay, so so basically I have covered all the things that are needed for the revision. Okay. And we are going to take a break for 5 minutes. Okay, we'll come back at 10:15, and Yu Hao will be demonstrating on how we can use Python, okay, to process remote sensing data. Okay, so as I mentioned, Python programming is very important, okay, for processing of our data. Even if you use cloud computing, you still can have the options of having your own code in the cloud environment, even though cloud provides ready-made services. Okay, but of course, there might be certain things that we need to design ourselves. Okay, so we use Python normally for that. Okay, so we are going to take a break for 5 minutes. Okay, when we come back, Yuhao will be demonstrating the use of Python. Okay, so we'll take a break now. Okay, I'll see you in 5 minutes.